One of the focal areas here at the Department of Process and Energy is to enhance energy efficiency. In the past, a large part of our research and technological development at the Department of Process and Energy was focused on the utilization and processing of hydrocarbons. This has radically changed over the past years. Now, we enable the energy transition by educating future mechanical engineers and by developing novel processes and equipment.
We are living in exciting times. As a chemical engineer, I was trained in building refineries. But who's talking about refineries anymore? Except perhaps at the TU Delft. At the TU Delft we have the e-refinery program. And the e-refinery program is basically about the factories of the future, where we're using electricity to transform molecules just like CO2, water and nitrogen into the chemicals and the materials which we need for the future. And here in this laboratory, together with TNO, the Department of Process and Energy, are working on basically scaling this type of reaction. And here you see a nice example where you can see the transformation of CO2 to formic acid. But as well, you can make from CO2 molecules like CO or ethylene. These are molecules which we are still going to need in the far future. So here you can see then that electrons can really help us to drive our renewable economy and getting it towards a circular carbon concept, because that is what we need.
Nowadays we want to make hydrogen from renewable energy sources like wind and solar energy, and we have to pay very much attention to energy efficiency, making hydrogen very cheap. One of the things that hampers the efficiency of hydrogen production is the formation of bubbles. I study that through theory, simulations and experiments. What you see here is a model electrolyzer. Bubbles come off and they are nice in the sense that they drive a flow transporting heat away from the electrolyzer, but they also impede the electrochemical process and hamper the efficiency. By studying this in detail, making measurements, using theory, we can in the end make better designs for electrolyzers and make hydrogen cheaper.
What we have to realize is that during an energy conversion process, we produce heat. By utilizing this waste heat, we can increase the energy efficiency of any energy system. We will do so by investigating novel heat pumps, for instance, but also by gaining a more fundamental understanding of heat transfer at the smallest scales. So we also investigate heat transfer involving phase change materials, but also heat transfer at supercritical pressure. We also look into advanced heat networks. And by doing so, we hope to increase the energy efficiency of both current energy systems and future energy technologies.